Welcome to this exciting Java programming tutorial. Today, we are going to explore an intriguing topic, the rail-fence cipher. This classic encryption technique dates back to the times of the Roman Empire and serves as a great introduction to the world of cryptography. Let's dive into the details. In this video, we'll learn how the rail-fence cipher works, how to implement it in Java, and how to encrypt and decrypt messages using this technique. By the end of this tutorial, you'll have the knowledge to create your own encryption tool using the rail-fence cipher. Let's start by understanding the concept behind the rail-fence cipher. The rail-fence cipher is a form of transposition cipher, which means it rearranges the characters of the plaintext to create the ciphertext. The characters are written in a zigzag pattern across multiple lines, resembling a fence. This zigzag pattern is then used to read off the ciphertext in horizontal lines. To illustrate how the rail-fence cipher works, let's consider an example. Suppose our plaintext message is "Hello World." For a rail fence with 3 rails, we write it as follows. In this example, we write the characters in a zigzag pattern. Once finished, we read each row from left to right. So, the ciphertext would become "Hor ELWLDLO." In this tutorial, we'll build our Java application that follows this pattern for both encryption and decryption. Next, let's set up our Java project. You can use any IDE you prefer. I'll be using IntelliJ IDEA for demonstration. Make sure you have Java installed. You can check this by running Java version in your command line. Create a new Java project named rail-fence cipher. Then, create a new class file named rail-fence-cipher.java. This is where we will implement our encryption and decryption methods. First, let's create our main method, which will be the starting point of our program. We will also create 2 methods, one for encryption and another for decryption. Let's set up our class structure. In the encrypt method, we will receive the plaintext and the number of rails as input parameters. Our task here is to construct a zigzag pattern and read it row by row to form the ciphertext. Let's first declare a 2D character array to represent our rail structure. The number of rows will be equal to the number of rails, and the number of columns will be determined by the length of the text. We will also initialize a variable to keep track of the current position in the zigzag writing process. Next, we need to fill this rail matrix in the zigzag pattern. We will iterate through the characters of the input text while moving vertically downwards, and then when we hit the last rail, we will move diagonally upwards until we reach the top rail again. With our rail matrix filled out, we now need to build the ciphertext. We will iterate through each row of the rail matrix and concatenate all the characters to form our encrypted string. Now that we've implemented our encryption method, let's move on to the decryption process. The decryption process will work similarly, but instead of creating the zigzag, we'll identify where the characters should go in the rail matrix. First, we need to set up the rail matrix and then fill it with the characters from the ciphertext following the zigzag pattern. The next step is the key component of the decryption process. We need to traverse the rail matrix and fill it with the characters from the ciphertext based on the zigzag pattern we created during encryption. This means we will also need to keep track of our current position throughout the zigzag. After filling the rail matrix with the ciphertext, we can construct the plaintext by reading the matrix in the normal zigzag order. We can now check our implementations. In the main method, we'll create a simple test case to see our rail-fence cipher in action. Let's run the program and see if our implementations work as expected. If you followed along, you should see the encrypted message along with the decrypted message matching the original plaintext. Congratulations! You've successfully created a rail-fence cipher encryption and decryption tool in Java. This illustrates the importance of understanding basic encryption techniques and how configurable parameters like the number of rails can impact security. As a challenge, try modifying the code to handle additional cases, like supporting input with spaces, special characters, or even implementing user input for dynamic encryption and decryption. Thank you for watching this tutorial. I hope you found it helpful and informative. Be sure to subscribe to our channel for more Java programming tutorials and encryption techniques. If you have any questions or suggestions for future videos, please leave them in the comments below.